Hey there, today we're going to talk about right triangle congruence. This can be found in your textbook somewhere near section 4.6. There's other things in that section though, so just focus on this HL, hypotenuse leg congruence theorem. Okay, hypotenuse leg. Well, there's a word in there, hypotenuse. The only type of triangle that has a hypotenuse is a right triangle. So that means that this HO can only be used for right triangles only. Okay? Here are some pictures to help you see what this looks like as far as triangles. So you must have a right triangle. It's got to have the 90-degree angle mark. You must know that both the hypotenuses are congruent. So there must be a tick mark on the hypotenuse from each triangle. And then you also must know that at least one leg is congruent. So in this case, I just chose these legs. Or it could look something like this, where it's still a right triangle, both the hypotenuses are congruent, but these legs are congruent. Okay, remember we learned something kind of like this in the past. If you've got a triangle like this, something like this, these triangles may or may not be congruent because this would be SSA. We don't know if that's enough information because this is not a 90-degree angle. So we don't want to put SSA. Instead, we always want to write HL if it's a right triangle. Another way that you can visualize the reason why HL works is if you've got a right triangle like this, would it be possible to figure out the other leg? Well, yeah, for a right triangle it would be, because you could always use Pythagorean theorem to solve for the last leg. In a triangle that's not right, like these over here, would it be possible to solve for the last leg? No, because you can't use Pythagorean theorem. There's no way to really solve for the exact measure as far as we've learned. Okay? So I can solve for this last leg. This would be 3. And if I have another right triangle such that the hypotenuses match up and one of the legs matches up, I know by the Pythagorean theorem this other leg is going to have to be 3 as well. And then I can see that all 3 of the sides are congruent, so the triangles must be congruent. This will always work for a right triangle. That's why HL works. Alright, now just because you have a right triangle does not mean that you're going to use HL every single time. So let's look at some examples. In example number 1, I've got 2 tick marks, a 90-degree angle mark, so that one's got to be 90, and I have a reflexive side. In this triangle, the hypotenuse would be the side directly across from the 90-degree angle mark. We don't really know anything about the hypotenuse right now, so we know right away we can't use HL. What we do know is we've got 2 sides and an angle in between them, so this would be SAS, the old shortcut. Example number 2, first check, make sure you actually have a right triangle. Yep, we do in both. Then check to make sure the hypotenuses match up. So in this case, yes. And then one of the legs should match. So example number 2 would be HL. Example number 3, you definitely have a right triangle. They give you the hypotenuse, but not another leg. Instead, they give you an angle. So this would be like the old shortcut that we've learned, AAS. Okay, see if you can figure out the rest of them, 4 through 6. If you don't think there's enough information, then just put none. Okay, on to the proofs. When are we actually going to use HL? So proof number 1, put out your given and then start marking up your picture. So AD is perpendicular to BC. That tells me that both these angles are right angles, which means that they must be congruent. So I'm going to name them 1 and 2. Angle 1 is congruent to angle 2 because we've got perpendicular lines. That's the nifty little shortcut we came up with. Perpendicular lines make right angles, which right angles are always congruent. BA and AC are congruent, and I've got an overlapping side AD, which means it's reflexive. Now, if I start looking at what's given to me, two sides and a right angle. That angle's not in between the two sides, so that would be SSA, but we know SSA doesn't really work. Instead, for a right triangle, we put HL, because hypotenuse leg. So it's just like all the other proofs that we've done, but instead of using SSS, SAS, ASA, or AAS, specifically for a right triangle, we could use HL. Alright, going on to number 2. List out your given. D is the midpoint of CE, so that tells me CD is congruent to ED. Use this word again to help you figure out the reason. Definition of midpoint. Also told us BD and FD are congruent and that these are right angles. So if they're right angles, that means that they're congruent. Angle C is congruent to angle E. Right angles are congruent. And I've got a hypotenuse matching up with a hypotenuse. And both the legs match up. So I can say that these triangles are congruent by our new theorem, HL. Done. Okay, number 3. Number 3's got a lot of information. So you would list out all your given information here. Then I'm just going to mark up my picture. UV, XW, UZ, XY are congruent. And these lines are parallel. VW is perpendicular to VZ. That's these two sides. So that means this angle is a right angle. I'm going to mark that as angle number 1. Also, VW is perpendicular to WY. This one. Which means this has to be perpendicular. So I'm going to name it angle 2. Okay. Well, perpendicular lines form right angles, and right angles are congruent. So that means angle 1 is congruent to angle 2. Okay, but those angles aren't in the triangles that I want. I'm trying to show that these triangles here have to be congruent because I'm trying to show that U and X are the same and U and X are corresponding parts of those triangles. So first I have to say that the triangles are congruent. How could I do that? Well, there must be a reason why they told me that these parallel lines are in here. If I've got parallel lines, that's got to be 90 degrees because it's alternate interior with angle 1. So I'm going to name that angle 3. And I'll name this one angle 4. So now angle 1 is congruent to angle 3. And angle 2 is congruent to angle 4. Because if we have parallel lines, if lines parallel, then alternate interior angles must be congruent. Before we said that 1 and 2 are the same. So that means 3 and 4 have to be the same by substitution. And if 3 and 4 are the same, we've got right triangles with hypotenuses matching up and legs matching up. So triangle UVZ, U matches up with X, V matches up with W, and Z matches up with Y by HL. Alright, if those triangles are congruent, that means all the corresponding parts that are left over are also congruent. So therefore U and X are congruent because of CPC/TC. And that's all. Hopefully this helped you learn what HL theorem is, hypotenuse leg. Remember, you only use it if you have a right triangle. But if you have a right triangle, it does not mean that you only use HL. You could still use all the other theorems that we talked about in the past. Okay? Thanks for watching. Hopefully this helped you out.